is my favorite subject and a very challenging class. And if you ever take it, you should do more than just pass. In it we learn equations, linear, quadratic, and more. We always...
Hey guys, Mr. Ing here. Let's go over the quiz before the winter break 2.1. This is version D. The leading coefficient is the one in front when it's in descending order. So descending order refers to when you put the largest degree first. And then you go with the next one. And this is the last one. Okay, so then the leading coefficient is actually 11. Okay, this one is asking you for the degree of the polynomial. This is just the largest exponent or power. So your choices are 4, 3, and 0. So 4 is my correct one, so this is a 4th degree polynomial. Okay, which one is a polynomial? So green light, what is a polynomial? You know your base is going to be a variable. So the bottom one, like this. So this one's good. And your exponents, or your power, that's this one up here. These will be whole numbers, not negative, fraction, decimal, or a variable. Okay, so that's how you know. Let's see, this one's okay, and this one is okay. Now, it's not a polynomial if you usually have a number, or any of these happen. Those are yeses, so you have a negative. So this, in this case, this is a negative exponent, therefore this is not a polynomial. So you could have chosen A, B, or D as your correct answer. And then list out one of your reasons why. So 2 points for the correct answer. You don't have to circle all of them, you just have to circle one. Okay, question number 4, end behavior. Let's draw a quick graph. We'll lift out the X, the Y's. These are positive numbers. Negative numbers to the left, negative numbers going down, and positive numbers going up. Okay, this box will stay the same. And the first one says as x approaches negative infinity. So this is essentially going on the x-axis, but you're going towards negative numbers, so you're going left. And as you go left, what happens on the f of x, or the y-axis? Well, the graph does positive infinity, so that just basically means up. So I go left, up, and that's why I'm drawing the arrow there. This one is saying as you go towards the right, x approaches positive numbers, then you're going to go also. So you're also going to go up. Okay, so here's my graph. It looks something like this. Okay, well, if you look at your parent graphs, the most basic ones, x to the first starts down, ends up, and x to the second starts up, ends up. So this is even degrees, and these are all odd degrees. Well, we have the arrows together, so we essentially have an odd degree, even degree, and the arrows are staying up. So that would be a positive leading coefficient. What is a negative one? A negative one would say, you know, negative x squared. That means your graph would go down. Okay, so essentially end behavior is just how it starts, how it ends, where are the arrows. Let's go to the can. You only use positive numbers 1, 2, and 3. They should not be repeating in rows and columns, but they can repeat in cages. So let's see if this one has a cage. This one does have a cage. So a cage is this. Okay, so in there, those numbers can repeat. So, for example, it would not work, but this would be okay if I could. So the ones are in there and they're repeating, but you can't have 6. You can only use numbers 1, 2, and 3. So sometimes you can guess, I don't know, 3, 2, 1. Now over here, these are two numbers that divide to be 3. So I'm going to choose 3 and 1. That means I'm left with about a 2 and 1. So 2 minus 1 equals 1. That works. And then let's try the last one. I'm missing a 2 and a 3. Uh-oh. Let's see if I can switch some numbers here. Can I do 3 and then 1? So I want the 3 to be down here. I want this number to be a 1. It's not working, so I can switch it. Let's try this. 3. 2, 1. This would be a 2, and then this would be a 3. Oh, that does not work. Because then I get a number too big. Switch my numbers here. Three and 1. Nope. Okay, question number 5. We can use the numbers 1 to 3. In cages, you can repeat numbers. So that cage you could repeat. Okay, I want to try 1 and 2. Because that is 2 divided by 1 equals 2. Then about 1 and 3, because 3 divided by 1 equals 3. Okay, let's try the harder one. So this would be 3, 2, and 1, because 1 times 2 times 3 equals 6. And then that works. 3 minus 2 equals 1. So that one works. Okay, Number 6. Explain why f of x equals 5x squared plus 7 is even using f of negative x. So this is basically saying we want to test for its symmetry algebraic. And we wrote in class with the star, sub, and negative x. That's hard to read. Sub a negative x for every x value. So that means this will become a negative x and this will become a negative x. Okay, we're going to use PEMDAS, so you're going to use exponents first. So negative x times negative x is x squared. And I have 5, so 5x squared plus 7. Okay. So why is it even? You know, you have even, odd, or neither. Even is equal to the original. So follow along. Let's use green. This is the original. And then after we put in negative x, they're exactly the same. 5x squared plus 7, 5x squared plus 7. So we can say when replacing every x value with negative x results in the original function, which means even symmetry. Okay, so I want to make this even more clear. What we did right here, I want to change that to pink. Okay, so basically we are replacing every x value with negative x, and then we simplified it. It went back to the original, that's why it's even.
Rudolph the statistician, simple data everywhere, nights and hard conditions, calculated with great care. When all of his population gathered from coast to coast, sought out his information, he would always give the most. Then one foggy Christmas Eve, Santa came to say, Rudolph, with your pencil write what gifts I should take tonight. Quickly he pulled the children, then Rudolph shouted out with glee, Stats did provide the answer, give Nintendo and Barbie.